Alright, this lesson is called How to Test Two Ratios to See if They Are Equivalent. Don't forget to write your date, the date today, in the top left-hand corner. We've been talking about ratios, and we know that if a giant 1 is used to connect two ratios, then those two ratios are equal. So for example, if we have 1 to 2 and we multiply by a giant 1 like 3 over 3, we're going to get an equivalent ratio. So on top we multiply 1 times 3 is 3, and on the bottom 2 times 3 is 6. And now we've got two ratios that are equivalent. 1 to 2 is equivalent to 3 to 6. They're equal. We use the word equivalent, means equal. The reason they're equal, and we've talked about this before, is that we are multiplying times a form of 1, right? 3 over 3 is the same as 1. And when you multiply something times 1, it doesn't really change it. Now with the ratios, it looks like it changes it because the numbers become bigger. But actually, it's still the same ratio, because if you've got 3 to 6, it's the same as 1 to 2. For example, if I have 3 stars and I've got 6 squares, we can make groups. Oh, I got confused for a second. We can make groups of 1 to 2. So if we had 1 star, like 1 star to 2 squares, like this, it's the same as 3 stars to 6 squares, because you can see each time we have another group of 1 to 2, 1 star to 2 squares, it's the same each time, but we have a total of 3 stars, 1, 2, 3 to 6 squares. But they're all in groups of 1 to 2. Okay, so we know from what we've studied that these things are true. This is review. But now I want to talk about how we could test two ratios if we weren't sure that there was a giant 1 that connected the two ratios. We could test to see if they are equivalent in a different way. So let's use the same example. We're going to call this example A, and we're going to say 1 to 2 equals 3 to 6, and we're going to pretend we don't know if those are equivalent or not. We're not sure. Alright, so here's the method that we use. What we do is we do something called cross multiply. Cross multiply. Okay? So with cross multiply, I learned it this way. I like to go up from the bottom. So I multiply across, kind of in a diagonal, going up that way. And I do the same thing starting over on the left side, going up to the right, and multiply up that direction. And what we do is we multiply the two numbers together. So the 6 multiplies times the 1. 6 times 1 is 6. And 2 times 3 is 6. And since those are equal, since 6 equals 6, that tells us that the ratios are also equal. 1 to 2 is equal to 3 to 6. So let's write that down. If the product is the answer we get when we multiply, so we just got two products. When we multiplied 6 times 1, we got 6. That was a product. And 2 times 3 is 6, and so that 6 is also a product. Okay? So if the products are equal, then the ratios are equal also. The ratios are equivalent. Okay, so here's the rule. Cross multiply. And then if the products are equal, then the ratios are equivalent. So let's look at a couple more examples. Example B. Let's try 4 to 5 equals 12 to 13. Okay, so those are two ratios we could look at, and we probably would say, I'm not sure if those are equal or not. I mean, it says they're equal, but we'd have to test it. If the question, like it was on a test, it said, are these two ratios equivalent? We'd have to test it out. So I'm going to use my calculator to do the cross multiplication. So remember, what we do is we go from the bottom up diagonally. So we would do the 5 times the 12, and we would do this 13 times the 4, and see if they come out to be equal. So let's do the multiplication. I'm going to do 5 times 12. Some of you have that memorized. What's 5 times 12? 60. Okay, so I'll write that down. 5 times the 12 was 60. And then clear that. 13 times 4. 13 times 4 equals 52. Not equal. So these products did not come out to be equal. So we would say these ratios are not equivalent. So instead of having to draw a picture of, for example, like I drew a picture of stars and squares, or instead of having to do a giant 1, sometimes giant 1 is useful, and we can easily do it because we can tell what it is, like in this one right here. We have the giant 1, but here we look at it and we wouldn't know what the giant 1 is. We'd have to try to guess, and it might take a while. A quick way of testing to see if the two ratios are equivalent is just by doing this cross multiplying. And it turns out these are not equivalent. What I want you to do now is I want you to try this one on your own, and then when you're done doing this problem, then you're going to start the video again to see if you got the correct answer. So go ahead and use a calculator to do the cross multiplication on this problem, and then see if they come out to be equal or not. And then when you finish and you get your answer, then turn the video back on. So go ahead and pause your video. Alright, so when you do the cross multiplication, you should have gotten 4 times 30 is 120, and 10 times 12 is 120. So they do come out to be equal. This one is equal to that one, and therefore yes, the ratios are equivalent. All right. All right, I want to show you something that you might see on a test, like at the end of the year when you take the SBAC test, or maybe on the MAP test you might see something like this. It might seem a little complicated, but I'm going to try to explain it really well for you. So what you might see on a test is you might see a question like how can you test to see if these ratios are equal? And then when they ask you that, they might give you some multiple choice answers, and what they're looking for is they're looking to see if you understand this idea. They put A over B equals C over D. Or some form of that. I think that's how they usually organize it, is A over B equals C over D. But the main point that you have to understand is that they're putting letters in there to represent numbers. So the A is in the position where the 10 was on example C, right? So instead of putting 10, they're just putting an A in there, which means it could be any number. That's why they use a letter. They're just saying this could be any number. And then B is in the place where that 4 was on example C. So B is there because it could be any number also. And that's the same thing with the C and the D. They're just putting letters in to show these are spots where numbers could go. But from what we've learned about cross multiplying, we know that we have to cross multiply the B, whatever number is in the B location, with whatever number is where the C is, right? So it'd be B times C, and D is going to multiply times the A. So they would write something like this on the test. They would put an answer where it would say AD equals BC. All they're saying when they write that is that you did A times D. When you put two letters next to each other like that, with no symbols in between, it means you're multiplying them. So really AD just means A times D. And the same with the B and C. B and C right next to each other, if there's no plus or minus sign, you just put the two letters next to each other, it means you're multiplying them. So this is B times C. So we would test to see if these ratios are equal. It says, how can you test to see if these ratios are equal? Well, just like this, we would do the A times the D, and we would do the B times the C. And that's what this is. It's just showing that we're looking to see if those products are equal. Same as what we did when we multiplied with the numbers up above.